I'm not expecting that we're going to go for 4 hours, so bear with me. My name is Blake Ericson with Montrose. Tennis by nature has done a lot of FTIR over the course of my career. Here to talk to you today about generating really good quality data in the FTIR space. This is something that we are passionate about. We are trying to push forward. We're going to go over a little bit of what you should be looking for as a customer, vendor, investor, just some general things that we kind of see. We've seen all sorts of stuff, damaged equipment to bad equipment to training, you name it. So just a general overview, just know stack testing is really shaky. I think we all kind of understand that. All in the environmental space, we've seen it time or two. So we know that this is very difficult on people and equipment, but there is a right way to do this. So we want to make sure that we have good equipment, good training, we have the proper QA/QC programs in place, and other than that, we really want to hit home explain our FTIR data validation. If there's anything that you take away from this, please validate your data sets. So reality of emissions testing. Anyone here know stack testing? Ever heard of stack testing? Couple nods. Don't know. Just a little quick story about me. When I first graduated college, I had no idea what stack testing was. Not even remotely. Didn't know it was a thing. I knew there were stacks. I didn't know you could actually go out there and test this stuff. And going back to when I was interviewing with a company, it's called Prism Analytical at the time. I had a colleague named Mary Wells. She mentioned and showed, hey, this is really cool job, lots of travel, you're going to get to see a lot of things. And she showed me a picture of where hell she had just come from. I don't know if it was Conference, but she played it a little bit. It was on a white sandy beach down in Florida. And at that point in time, I was like, I'm going to do this crazy job travel. I get to go see it based on the years. Well, fast forward 8 years later, I'm still looking for those white sandy beaches. I stack tested in little practically everywhere, usually not in resorts towns, a lot of manufacturing facilities. So that's just the nature of the game for what we do. Stack testing is always amazing. There's another guy in our company's named Pop, thinking he may or may not have heard of him. He's been doing this for a lot longer than I have. He's taught me that stack testing is the only industry that we know where you actually start with top and you work your way down. That's how you actually find the corporate ladder of success with stack testing. So I always thought that was interesting. It's always stuck with me. And for any of you that had any fit in stack testing that came before us, because it is a tough gig. As you can see, that gentleman up there, he's got a rope and a 5 gallon Home Depot bucket. He's going to pull that thing up dozens of times and pull up all the pumps, monorails, you name it, to get you, the customer, to regulate it really small. It's quite a lot of work to get really good data. So like I said, started with a company where we were subcontracted under a lot of major firms. I get to see a lot of cool things. Still to this day, we do a lot of services, primarily on the MKS, 30 units. We also do some work with our Analytical. We have some instrumentation as well. And largely what we see, you can see in the picture down there, everything from block dusty fans to mess up in the barometers, all sorts of broken head lasers, you name it, we can fix it. But it goes to show how important having good equipment is. Because no matter how good of a spectroscopist you ever are, you're only as good as your weakest chain. And that tends to be the equipment. That's really hard. So no matter how good you are, if you have a bad sample, if you have losing temperature, if you have a leak, if you have crummy equipment, there's nothing you can do. So for your test teams, make sure that they have good equipment, they're well trained, and you have a good operator. If you don't have good equipment, everything we do is based on regulation. So EPA method 320, 321, 318, there's a whole slew of these that we use in our source testing world. It makes QA/QC for these methods very hard to pass and get really good data. So premise of this slide, have good equipment, have a well-trained operator. If you are a statesperson or a customer or even a investor, ask technical questions. Don't be afraid. I'm putting this thing called a black box, blue box, random number generator. I don't want that to exist in our industry. Because really, when it's in the right hands, it's a very powerful and accurate tool. Typical field mistakes, we're not going to hit this slide too crazy, but generally what we see in the field is really treating FTIRs like other analyzers. Once again, we know it's a tough industry. The FTIR is not a seal or a novice analyzer. It's a laboratory grade instrument that we use in source testing. So it's one of these things where, as much as we would love to throw it into a truck or keep it in a rack, drive it down the road, they're delicate. At the end of the day, they have shock mounts and all sorts of good things to help prevent against any wear and tear. We still have pretty delicate pieces. Once again, we'll have a quarter grade. One other thing with the FTIR that we tend to see is rushing, not doing proper checks, stack testers, and always on a home timely manner. But I can assure you that sometimes when we rush tests, we're more prone to make mistakes. And this is especially true because there are options in the FTIR where you can these things called scan factors. Scan factors are essentially just a way to multiply a number to make it match gas. Really, you don't really want that to happen. The FTIR should be working well enough to a point where you shouldn't have to use scan factors. If you really have to put these into play, you really should look at your calibrations, recipes, methods, and also other things. The difference with a CO or an NOx analyzer, right, is that calibrate on site with actual gas, where you can scan that solder on zero. So for me personally, the reason why I started being proponent of the FTIR is that data would come on site and you revisit it. I don't think that can happen on a lot of other information. Lack of training is a big one. We do a lot of training in FTIR testing. We've seen a lot of things. It's kind of like being told, right? If you pass along training, someone gives you helpful hint that may not be the right way to do things. Eventually it becomes a systematic problem and everyone's doing it for a while. So having someone that trains the right way is not taking a shortcut. That is absolutely critical. And other than that, it's just that learning on the fly and doing proper sampling. You got to filter with an FTIR. There's really no way around it, even on a natural gas turbine. Things get picked up. A little bit of particulate will mess with your signal. That will actually impact the results. So taking all these into account, really the big ones that we see are, loss of temperature, loss of flows, all those sorts of things. They may not impact certain gases. So if we're using FTIR for NOx, CO, methane, at the end of the day, that temperature isn't going to have as much of an impact as CO. Ethanol, savory gases. These are very temperature-prone substances. We always say what you're sampling at in the FTIR should match what the calibrations are. You won't always see. You see a little mixed bag of each, and we just kind of expect that we're sampling what should match the calibrations. This is especially true with some of the upcoming technologies that exist. This is a Starboost FTIR, for example, and this is the modified and optically upgraded instrument where we can see parts of the parts of the building on single digit. The Starboost is manufactured by a company called Max Analytical out in Connecticut. Good group of people. We use a lot of their stuff. But when you take all of these equipment issues into play, this really impacts the system a lot. Okay? What it does is it just sucking down particulate, or if you're running from equipment, you can't really say the professionals of that. We're talking really, really low stuff here. So at the end of the day, it's not an instrument issue. But if that peak there, which is the actual signal strength, takes any bit of a hit, we're really sacrificing our detection for really low compounds. Essentially, the better your signal noise, the better your detection. Real quick, how the FTIR works, very simple screen. We have irograms, which are converted to actual single beams, which go to orbits. Now, we're not going to talk about the math today. I know it's the end of the day. We're already tired. It's been a long day, so I'm not going to push it through some of the numbers. You have order transform. But what the FTIR is doing is taking that single beam, that's the whole area. You see that picture way up there at the top right, gives us wide absorbance of all sorts of things. So the beauty of the FTIR is that it can see many, many compounds, hundreds of compounds. It can't do everything, but it allows us to see these things in real time. Once again, a healthy instrument goes a long way. Little example, it's going to be real hard to see from where you guys are sitting, but this is an example of a cold spot and how it impacts certain gases and not so much in others. So on the bottom left, we have CO, middle right, NO. You can see that kind of nice, it's kind of a flat plateau, not so temperature dependent. This is actually a really recent data set that was sent to us. It was just 2 days ago, I believe, a customer sent this. As you can see, having a cold spot in the line, this is very indicative that something wrong is going on in the sampling. If you look in the top left, they're sampling for ammonia, and you can see the spikes kind of match and coincide with the water. That's going to happen when you have just one cold spot. So if you have a 100, 200 foot sample on it, you have a 50-foot section that's not going to get there, you're going to run into quality issues. That's how sensitive this instrument is. There's a really good chemist, a really good analyst will know, all right, my water's bouncing around. Shouldn't be doing that on a source. It should be pretty solid. Maybe a little bit, and you should never see that. So in the case of that, we gave them a call and said, hey, look, change out your sample lines. Once we collect good data, how do we know we did a good job? Well, this is arguably, like I said, the most important part of what the test needs to have from a testing or regulatory standpoint. So like I said before, ask your firms, do they validate their data? It's a checks and balances process. You want to know, if we do a good job, are the numbers that we've got correct? Because a lot of these have huge implications, whether you're developing emission factors or you're trying to figure out what's actually going on a process standpoint. There are huge dollars that are attributed to what data we collect in the field. So if we're unsure of the data, how can we confidently give that to the customer and say, this is what your number is? You know, we're not just trying to check a box and want the next test. We want to make sure we're giving them good stuff. Should be noted that the recipe, when you are collecting samples, needs to represent the entire gas matrix. So just because you test for ammonia and say water, doesn't mean you should exclude NOx, methanol, all sorts of other interference that might be in the cycle. Because if there is a major interference, it could be very much so impacting your data set, thus giving you a wrong number. At the end of the day, I think one of the biggest draws to the FTIR is that it's a self-validating instrument. And I use air quotes there, but it's, at the end of the day, I don't think any such instrument really exists like that. That's where validation from a third party or having a chemist or whoever on site actually check the data is so critical. Because the FTIR will lie. There's no way around it. I wish I didn't have to say that, but it is a very real circumstance that we have to deal with. So brief history of FTIR analysis, and luckily for us, we got a guy here that knows way more about this than I do. But back in the day, this is before my time, they were actually taking spectra on paper. You had to know your chemistry, where to look, and the whole set of analysis. And that's how you actually determine what the concentrations were. My former boss, who I still work with, his name's Phil Coffey, he always drove these into us when we first started. He's like, what is this? Where is it found in these organs? What should the concentration be? I never really understood why. Well, I think it's just because he had a hard time there. So he was paying it to us to make sure we had something as much as he did. What is data validation? You basically have three tiers here, right? You have the FTIR diagnostics, data analysis, and QA/QC. Basically, what this slide is saying is that QA/QC validation is in the methodology for FTIRs. I'll speed up. There's a whole reason why we do this. You know, from the FTIR standpoint, we're looking at line shape, signal intensity. We're just confirming that the FTIR is the best fit for the job and it's in good shape. As for data analysis, we're just making sure that that data is right. We have to add or remove compounds to make sure the data is right. And we validate the data. And in terms of QA/QC, this is the stuff we do on site. We're actually sending spike gas, down gas through the system. And we're ensuring that the data that we're reading down that we're sending on site is accurate. Making sure that we're doing a nice job. This is an actual example. Once again, it's going to be a little tough to see as to why validation is so important. A little backstory behind this: we were at a fiberglass facility. They were really interested in their methanol numbers. And long story short, had we originally reported the methanol number as is, we would have given them a failing value. And had we not validated it, we would have just given them that monthly validation, confirm that the number is actually lower than what was originally going to be set. This is where that FTIR lied to. So some of you may have seen this before. This is just subtraction. This is how the FTIR will actually validate the data. We go through all the main interferences one by one. You see the spikes, the valleys. You see this kind of big, ugly spectra on the bottom there. So if we subtract out the water, ammonia, CO2, we're left with this big unknown hill. And this is what was actually impacting our data to the point where we didn't know what this was, but we added it back into our data in the process. Gave us a value of about 2.6 ppm on the methanol, when originally we were reporting something more like 5, 6, 7, which is too high. So that's why the steps are so critical for validating, because had we not done that, we never know that there's this big ugly unknown in our spectrum. We can ask for a wrong number.
How much extra time is that take?
Depends on the set. Really should take, if you do it on site, so we recommend that our spectroscopists may want to test and review checks as they go. Certain companies have different parameters for QA/QC. For us, we do it a minimum of a couple of checks per monitor. So some people don't do it at all, but it is such a critical point, and especially on like chemical facilities, refineries and stuff. You're looking at really nasty substances. So it really depends on the firm. As for the methods, what all three of these slides go through, we're not going to harp all the words, is essentially that data validation is necessary in the program. You have to have it. There's no way around it. But oddly enough, it's so strange to me because in the source testing world, we have QSDI, QI, all these different things to make sure that other stack testing methods are going well and people are well trained. We don't really have anything in the FTIR space. To me, that's kind of alarming. It's like one of the most, arguably one of the most technical pieces of equipment we have in our arsenal. But it's basically allowing anyone to go out there. As for what requests should be made, if you're a state customer, whoever, you're going to put this in the report, ask about the physical elements of the FTIR, what model are you using, what's your pathway, why are you using what you're using. You want to talk about QA/QC. At a minimum, you need directs, system checks, CTS, which is calibration transfer standard, spikes, good cylinders, all that sorts of good stuff. And you want to make sure, once again, you're really hitting that validation package at the end of your test to make sure that it's going well. We're starting to see ever so slowly that state and regulatory agencies are getting a little bit more sharp with this stuff. Whereas before, they kind of just came on site, did a little check, made sure that their testing was good, not the par, off they went. You know, they never really understood what they were actually asking for, looking at. And what we're finding is that some states are starting to be really good at this stuff. So they're asking for the spectrum, they're asking for the validations. We expect that it's only going to continue as we move forward. What is the end game? I told you we get caught up. Like I said, at the end of the day, we want to get moving. But my firm belief is that the FTIR is a major tool for our industry. And unfortunately, I think with some areas of the country, some individuals, it's given a bad name to the industry. What I think could happen is that with proper training, asking the right questions, you know, just branching out in that way, we could really bolster the FTIR application. It's been around for about 20 years now. Some companies have really put up a good fight trying to put it on the map. But unfortunately, like I said, the barriers of entry to stack this are so low that it makes it really, really hard to prove to some state that it is a viable tool because they've been burned before. That's the hardest part for me is to say, look, you got burned, you know, give us a shot. It's like, oh, no, they've been burned one too many times, so they're not going to do it. I don't blame them at all.
So I think as a whole, we can be a lot better as an industry.
Is the note too that the FTIR is not perfect tool. It can't be used for everything, but it's a really great tool when it's used in the right hands. You can't do metals, you can't do like certain chemistry methods, and that's fine. But I think for a lot of applications for what we do, the FTIR is the way to go.
As I said,
Foundation data.
biggest thing I want you to take away from this discussion, and let's just continue to bolster that FTIR reputation together.
Good. Any questions?